welcome to the AI Checkpoints. Today we're diving deep into something super important, but honestly, often a bit mysterious. It's about how these large language models, the brains behind the AI we're starting to see everywhere, are actually trained after their initial massive learning phase. Think of it like going from a raw, incredibly smart, but maybe unfocused brain to one that really gets what you need and how to deliver it. It's complex, it's moving fast, and it's really where the magic happens for making AI truly useful day to day.
Exactly. Our mission today is basically to pull back the curtain on this whole process. People call it post-training, sometimes fine-tuning. It's absolutely key. It takes a model from just impressive potential to being genuinely indispensable. We've looked at your sources, researchers, industry folks, the details to kind of show you what's really going on, why it's such a big deal, and how these models are getting so capable heading into 2025.
Okay, let's get into it then. What is post-training, really? We all hear about these giant base models trained on, like, the whole internet, but that's just step one. I saw somewhere, I think researchers at AI2 maybe call it language model adaptation. It's this whole process of taking that raw knowledge and making it, well, useful, aligning it, making it respond the way you actually want it to. It's kind of like that brilliant, but maybe socially awkward genius learning some manners, right? Learning how to apply their smarts in the real world.
That's a great analogy, actually. It really fits because pre-training, as some analyses point out, gives the model its broad understanding. It learns to predict the next word, the next token, foundational stuff. But post-training, that's all about refining it, specializing it, teaching it how to follow instructions properly, making sure it's safe, developing reasoning. And historically, this really took off with a three-phase approach that became super popular with models like Instruct GPT and the first ChatGPT.
Okay, three phases. The first one, SFT supervised fine-tuning, sounds like the real starting point for usefulness.
It absolutely is. SFT is the core. It adapts the base model to the style of interaction you're looking for. Think of it like teaching the model the template for a good answer, or how to structure a summary.
So it learns the format, question, answer, that kind of thing. What struck me from one of the videos we looked at was that most of the performance gain actually comes from just this initial formatting stage. SFT.
That's right. A raw base model doesn't inherently know how to follow instructions. It just predicts. So SFT uses examples. You can use human-labeled examples, prompt response pairs from places like Stack Exchange or Reddit.
Okay, human data. Makes sense.
But here's where it gets really interesting, and multiple sources point this out. You can also use stronger AI models to generate high-quality synthetic examples, much faster than humans. Like the Tulu 3 project, that was highlighted somewhere. They got huge performance jumps, like 9 or 10 points on their tests, just by improving the SFT data mix using synthetic data.
Wow, okay. So better examples, even AI-generated ones, make a massive difference right at the start. So once it gets the format down with SFT, you need to teach it what a good response actually is, right? Yeah. Not just the right format, but helpful, safe content.
Exactly. That leads to phase 2, training a reward model. You need a judge. An AI judge, essentially.
How do you train a judge?
You collect comparison data. One source explained it well. You take a prompt, generate multiple different answers from the model. Then a human or maybe even another AI ranks those answers, best to worst.
Okay, so you get preference rankings.
Precisely. And that ranking data trains the reward model. Its job is to learn to predict which response is likely to be preferred. It outputs a score, basically, a number saying how good the response is according to those preferences.
Got it. So SFT for format, reward model for quality assessment. But you said things have gotten more complex than this original three-stage thing.
Oh, absolutely. That simple pipeline has evolved big time. Now it's much more complicated, iterative, multi-stage. We're talking about using synthetic data at a huge scale, millions of examples potentially at each step. And the big labs, OpenAI, Anthropic, Google, they keep their exact recipes pretty close to the chest. It's their secret sauce.
Right, the competitive edge.
And this complexity really pushed innovation in the third phase, optimizing the policy. Nowadays, we often call it preference fine-tuning. It influences the style, the chattiness, the personality almost. But it raises the question, you've got this reward model that scores responses. How do you use that score to actually make the main language model better?
And that's where this PPO versus DPO debate comes in, isn't it?
Yeah.
PPO, proximal policy optimization, that was the standard for RLHF, reinforcement learning from human feedback, for a while. Powerful, apparently, but really complex. Needs multiple models training at once, including this critic thing.
Yeah. PPO is effective, but notoriously tricky to implement and tune. That critic model adds a lot of overhead, which is why DPO direct preference optimization made such waves. Multiple sources highlight this. DPO basically found a way to skip needing a separate reward model and the critic model.
How does it do that?
It uses a clever loss function. It directly optimizes the main model based on the preference pairs, which one was ranked higher, which lower. It just makes the whole process so much simpler to implement, more accessible.
But is simpler always as good? Is there a performance hit?
That's the million-dollar question. Some analyses, like Nathan Lambert's work, suggest PPO can still squeeze out slightly better performance if you have massive resources and time to tune it perfectly. But for many, that tiny extra gain might not be worth the engineering nightmare. DPO gets you like 99% of the way there much more easily.
A practical trade-off then. And I heard mentions of other methods too, like GRPO, trying to find a middle ground.
Yeah, group relative policy optimization. Used by some newer models. Tries to get benefits without the full complexity of PPO's critic. It's a really active area of research.
Yeah.
But underlying all these methods, PPO, DPO, GRPO, is the preference data itself. Where does that come from?
Right. You mentioned human rankings earlier.
Exactly. Human preference data is the gold standard in terms of low bias. It reflects real human values. But it's expensive. One source put it at maybe $5 to $20 per comparison. That adds up fast.
Whoa. Oh, okay, that's pricey.
Then you have AI feedback. Using another large model as a judge, or LM as a judge, costs way less, like less than a cent per comparison.
Huge difference, but what's the catch?
The catch is potential bias. AI feedback is very consistent, low noise, but we don't fully understand the biases baked into these AI judges yet. Human data is noisy, inconsistent sometimes, but maybe less systematically biased. Projects like constitutional AI from Anthropic relied heavily on AI feedback to scale up. It's a trade-off.
So AI teaching AI again, but with cost benefits and potential bias risks. Are there good open data sets using this AI feedback approach?
Definitely. Things like Ultra Feedback and Wild Chat were mentioned as examples. They've used AI judges to create massive preference data sets, openly available. And they've shown you can get really strong models like Zephyr or Tulu 2 using DPO on this kind of scaled up AI feedback data. It helps level the playing field.
Okay, so that covers preference tuning, but you mentioned the cutting edge. RFT, reinforcement fine-tuning. How's that different?
Right. RFT is super interesting. OpenAI confirmed they're using it internally. Unlike preference tuning, which is about style and subjective goodness, RFT focuses on verifiable rewards, objective outcomes.
Objective, like what?
Think math problems. The answer is either right or wrong, binary reward, or code generation. Does the code compile and pass tests? Yes or no? Or following very precise instructions like make every sentence start with A. You can easily check if the model did it. The key is the answer can be verified algorithmically or against a clear ground truth.
So it's light about is this helpful and more about is this correct according to this specific rule?
Exactly. And often you don't even need a separate big reward model. The model's own internal value estimates can guide the learning. You do need clever grader models, though, systems that can reliably extract the answer and check against the rules.
Fascinating. So for listeners building AI apps, hearing all this PPO, DPO, RFT, reward models,
Yeah.
it sounds overwhelming. Should they be trying to build this whole stack?
Probably not for most people. That's a key takeaway from folks like Nathan Lambert. Building that full post-training pipeline from a raw-based model is a massive undertaking. Months of work, large teams, huge cost. The smarter approach for most developers is to start with a strong, already instruction-tuned open model like Llama Instruct or similar, and then fine-tune that model on your specific task data. It's way more efficient.
Leverage the giant's work, then specialize. Makes sense. Looking at the big picture, though, all this complexity raises some big questions for the field, doesn't it?
For sure. There are debates like, should academic researchers be distilling knowledge from closed models like GPT-4? Industry labs do it because it's effective, a shortcut maybe, but it impacts transparency and reproducibility.
Yeah, and the gap between industry and academia seems relevant here, too. Industry iterates constantly based on user feedback, builds specific tests.
Exactly. They have different incentives, different resources. They focus on product robustness in ways academia often doesn't. And there are still fundamental things we don't fully grasp, like how do you reliably train great reward models? When is human data absolutely essential versus when is AI feedback good enough?
It feels like we're still mapping out this crucial post-training territory.
Definitely. Mastering these techniques, as one source concluded, is going to be key for scaling AI capabilities, especially towards more advanced reasoning.
So it really boils down to this. You start with these incredible raw foundation models, but they're transformed into truly useful specialized tools through this complex, evolving dance of post-training. That's where alignment happens, where general smarts get focused into specific skills. It's driving the whole next wave of AI agents. It's a massive effort, tons of moving pieces, evolving incredibly fast.
Absolutely. This whole area shows that while the base models get a lot of headlines, the real artistry, the secret sauce for usable AI, is increasingly in this post-training refinement. And it leaves you thinking, right, as we get even better at controlling this process, fine-tuning these models with more precision, how is that going to fundamentally change what we even expect AI to do? What completely new applications might pop up when we have these incredibly fine-tuned intelligences?
Definitely something to chew on. Thanks for joining us for this deep dive into LLM post-training. Hit like and subscribe if you like the content. See you next time.